Today we're going to learn hyperbolic functions, where we're going to learn how to find the domain, its asymptotes, and learn how to draw the function. Please subscribe and click the like button below. Given the function of f of x is equals to minus 1 over x minus 1. 5.1. Write down the domain of f. So the domain of a hyperbola you're going to look at its vertical asymptote. So the vertical asymptote is x is equals to 1. So therefore the domain is given by the x element of real numbers, but x is not equals to 1. Asymptotes of f. So if we are going to consider a standard form where we have a over x plus p plus q, the horizontal asymptote of this function is y is equals to q, and the vertical asymptote is x is equals to minus p. So in this case we have f of x is equals to minus 1 over x minus 1. So which means that the vertical asymptote is going to be x is equals to 1, and the horizontal asymptote is going to be y is equals to 0. 5.3. Sketch the function of f. Clearly show all the intercepts with x's and the asymptotes. So if we are going to draw the function, we have f of x is equals to minus 1 over x minus 1. And to find the x-intercept first, where y is equals to 0, so 0 is equals to minus 1 over x minus 1. Because we're going to do a cross multiplication, the 0 will multiply the x, meaning that there will be no solution for x. And then now we want to find the y-intercept when x is equals to 0. So f when x is equals to 0 is equals to minus 1 over 0 minus 1, which is equals to 1. So the coordinates is 0 and 1. Now we know our vertical asymptote, which is equals to x is equals to 1, this one here, and then our horizontal asymptote, which is y is equals to 0. So if we go to our function and we draw it on our Cartesian plane, this is y and this is x. So the vertical asymptote is equals to 1, so it's going to go somewhere here when x is equals to 1, and the horizontal asymptote is 0, so it's going to go straight here when y is equals to 0. So now, because the a value is less than 0, means that our shape will be in the second quadrant and the fourth quadrant. As you can see there, it's negative 1, so meaning that a is less than 0. So because our y-intercept when x is equals to 0, it's given by 0 and 1, which will be somewhere here where it's 0 and 1. So the function will go like this, not touching the asymptotes, and go straight down here, and then another function will come this side. 5.4. For which values of x will x multiplied by the f of prime be greater or equal to 0? So now the x is the x values, and the f prime of x is the slope. So if we are going to draw our function here, the very same one we did in 5.3, we know that this will be a vertical asymptote which is equals to 1, and here which is your horizontal asymptote equals to 0. So now your function goes something like this. So what we need to look at is the x values. So here in this side we have negative x values, and here we have positive x values. So here in the negative x values, we know that every digit here is negative. And looking at the function from the left hand side going to the right hand side, the function is increasing, so meaning that the slope is positive in this side. So now if you want to find the solutions, I want to say the slope, which is positive, multiplied by the negative x values, it will give you a negative solution. So meaning that it is not going to satisfy the answers that we want in this problem. So looking at the other side, the positive side of the x-axis, we know that here is positive, and we know that the slope is positive as it increases. So to find the solutions, we're going to say slope, which is positive, multiplied by the positive x values, will give you positive solutions. So this means now that here in 5.4, when x is greater or equal to 0, because from the origin to the positive side of the x values, we are getting positive solutions. And x must not be equal to 1. So we must make sure that the x values are not equal to 1, because this is where we have our vertical asymptote, and the function is not passing through this line.